So I think in general we're running a little late, which is perfect because my talk I'm going to make quite brief, and hopefully it'll be more interesting because I'm not quite sure what you guys want to hear from me, for you to ask me questions, and I think that'll be more interesting and interactive. I came up with this very verbose title, not quite sure why it was so verbose. I'll cut straight to the chase. At the moment, Netflix is an internet video service. It's IP-based. We deliver our content to carrier networks at their IP gateway through internet peering, and in some cases having embedded caches. I think the most interesting thing, and I'll talk about some of the challenges to do that, is to look at caching some of our video content much deeper in mobile networks, and potentially people in this room can help me work out how to do that. But at the moment, we have about 50 different sites around the world that look a bit like this. It's a whole bunch of caching infrastructure. These servers are incredibly efficient in terms of delivering bits. They do very little compute from a cloud perspective. They're really just taking bits off storage and putting them on a network interface, and support tens of thousands of streams per server. And so these are some of the densest internet nodes that exist, but because the problem set is very simple. So compared with like a Google and YouTube that are doing a lot of computation for a relatively small amount of data for, say, a display ad, we do almost no computation for a very, very large amount of video content. So let me tell you a little bit about Netflix. I'm hoping many people know what Netflix is. It's an internet television service. It's based in San Jose, or Los Gatos near San Jose, Silicon Valley. We also have a large office down in Beverly Hills because that's where large networks and studios are based in terms of content rights. We actually have a European office in Amsterdam. The service started streaming in '07. Domestically in the US, then went international in Canada, then Latin America, Europe, and we just started in Australia and New Zealand, and we're going to start in the rest, some of the rest of Asia towards the end of this year, and we have global aspirations beyond that. We have about more than 60 million subscribers, so it's been a very successful service. And as part of that, we generate an awful lot of, in particular, fixed broadband downstream traffic. So at peak times in our mature markets that we've operated for a year or two, we're often making 25%, 30%, 40% of downstream traffic is associated with our content or subscribers on those networks viewing Netflix content. So I thought I'd give you just sort of a number of sort of media slides that are put together off our website about the uses of Netflix and why it's a successful service. It started as a way to watch video content over the internet on televisions, but you see already in this picture like someone's watching some Netflix on an iPad or on a tablet. And so the service itself is highly personalized. Once you start watching it, either through rating in an active way or passively just based on what you've watched, we're going to recommend to you different types of content, and that constantly evolves. And that actually is part of the delivery problem, which I'll get to later. The fact that no two people are really looking at the same user interface. And so unlike merchandising of on-demand video, where there's a number of sort of advertiser-backed releases on a Tuesday about the titles everyone should try and watch, at Netflix, everyone's looking at different sorts of titles, and that churns the viewing library significantly more. There's also a special user interface for children and on tablets. And you see that more and more of these talking about watching when you're on the move, tablets in different parts of the house, phones when you're traveling, or relaxing in the park, or having a picnic with someone else, or when you're in bed with your wife and you're actually watching Netflix. So that's our idea, to become as ubiquitous as possible. We're on many thousands of consumer electronics devices across a wide range of televisions, set-top boxes, DVD players, game consoles, and then through the portable device spectrum. So I'm part of a group that builds the content delivery network. So I'm sure most people in this room are aware of what content delivery networks are. The commercial ones are companies like Akamai. It's a concept that was commercialized in the late 90s, which basically puts cacheable content deeper within the internet, so you don't serve it off a centralized server, you serve it out to where the users are. Netflix, as it grew as more and more successful streaming service, by 2011, when I joined, was already the largest consumer by like volume of the three largest global content delivery networks. And over a period of 2 years, we built our own content delivery platform and brought all that traffic in-house. A bunch of the reasons for that was, we have the scale advantage to be able to do that, and because as an external vendor content delivery network, which I used to run one, you have to satisfy many tens of thousands of customers in the individual use cases, and so there's necessary engineering compromises to do that. When you build one that's single purpose, you can make that very efficient in each generation of hardware and software, and so we could make that a very effective project with our amount of traffic. So we now deliver, as I said before, some of the largest downstream flows of traffic at peak time, which is typically in the evenings for us, in particular over the weekends. The other interesting thing is it's not really event-based. There's other large sort of internet video events that happen, once or twice a year, sporting events, for example, or big sort of national news type events. Our traffic shows up every single day. There's a large amount of it every single evening, and there's a very large amount of it on a Friday, Saturday, and a Sunday. But it shows up all the time, and it's a relatively effective use of network traffic from an interconnect point of view, in that we don't have to provision a large amount of infrastructure for the quarterly or yearly software patch that might make up most of that traffic. It's coming all the time. And sorry, this is a view of a bunch of the people associated with the project. So it's quite a large project now, about 50 people are working on it. About half of those are software engineers, and the rest are operators and network engineers. So one of the things I wanted to give you a little bit of background on is Netflix video clients are actually sort of a distributed computing environment, in that we stream our video by using HTTP, but adaptively the clients are using their own measurements of the network sustainability that they have to select the bit rates that they can play. And whether that's a web browser client, HTML5 client within a web browser, or across a mobile platform, or a game console, or a set-top box, or a smart TV, it uses this toolkit and the algorithms associated with it to make that decision right at the edge, right? So on the client device itself. Historically, there were streaming protocols, certainly around the time that Netflix first started streaming, that put an awful lot of that knowledge in the server side, and that made a much more complicated scaling challenge, because the server then has to try and work out what the best client experience is and deal with those metrics, potentially many thousands or tens of thousands of times. But we distribute that all the way out to the edge, and it means that our server infrastructure is very dumb. It doesn't have to keep state. It just returns files when the clients ask for it. That said, we do have a control plane. That control plane works in Amazon's AWS cloud. I should say Netflix uses AWS extensively for all sorts of its compute needs. We do a large amount of encoding of content into different bit rates and in some cases formats. And that's all done. It's a perfect job to do sort of outside peak in a cloud environment. And all the personalization, there's a lot of pre-computation that goes in to make that a very fast and efficient user interface, and that's all done in Amazon AWS instances. So one of the aspects around sort of our fresh start to think about how we're going to deliver this content is a lot of content delivery networks operate on a caching on demand level. And that is not necessarily the most efficient way to do it when you have very large files that people don't necessarily watch all of. And if you think of our most busy servers connected by 40 gig connections and the average bit rates 2 or 3 megabit, we're not seeing enough traffic, even in those very busy servers, to have the individual server work out whether something's popular or not. It certainly would be able to work out the absolute most popular content, but it wouldn't be able to work out whether a particular bit rate of a several-year-old TV show in the 3rd season, the 5th episode, is really popular enough to want to have the effort of bringing it all the way to this cache, or whether it should be served further upstream on the network. But what we're able to do, because we have extensive client metrics of every single play on the Netflix network, we can build up a large amount of statistics about what is the most likely content to give the most offload for the network operator if we put that content proactively. And we can push that out there in off-peak times where the networks are underutilized, and that content movement therefore is somewhat sort of free in the network sense. So we're doing this proactive caching, and then actually at delivery time during peaks, the server's going into a very efficient mode. It's writing almost nothing to the storage, and it's able to read out very effectively, and that also gains a bunch of efficiency for us. It means that sometimes the servers aren't serving the content for Netflix, but it's not because the content request comes to that particular server and it says, I don't have it, the request will never come. Steering mechanism knows exactly what content's on every server, and so we'll only send requests to caches that we already know have the content. And this gives you some idea of the effect of the deep personalization of the service, in that if you think of our mature market catalogs are about 1 petabyte of content, and to get a reasonable amount of offload, sort of in the 70 to 80%, you've got to get several hundred megabytes of the petabyte onto a cache, or potentially a series of caches, to be able to see that network offload. And if you have appreciably less than several hundred terabytes, you get obviously decreasing amounts of cache efficiency, to the point that if you only get like 40% or 50%, that's not a large amount of value, and it makes it a lot more problematic to think about the effort of running a cache and the overhead in doing that if there's still 50% of the traffic's never going to hit the cache. And so this is potentially a little different from certain types of popularity curves. I think it's driven by the very strong personalization that we have, and its pre-produced content. If you look at a similar curve for social media, it actually has potentially higher peaks for the most popular, highly viral content, and then obviously it has an incredibly long tail, which we don't see because we only have a limited active set of catalog titles. Sort of covered a little bit of this, but part of the project is to build the 50 sites that I showed an image of earlier. We also offer a caching program where we'll send caches to service providers to set up on their network. Again, on-demand video is not very latency sensitive, so the effect of moving a cache within an operator network, it's not improving the quality of experience per se, it's saving network build-out costs, and that's really the value here. Individual cache is serving around 100,000 subscribers on a internet network, and really that limit today is because of the storage cost associated with getting enough of the library to make it worth putting the cache there. You need about 100,000 subscribers on an internet network, on an ISP, to justify putting the cache, to make the cache efficiency high enough. This is a last-minute slide I put together. Sorry for the lack of axes. This is just an idea. There's actually some very faint lines here. This is 20% of the uptake over the last 2 years, and you can see it's sort of somewhat flattening off, of portable devices. So that's tablets and phones of the service. So you can see And I think that the top line's Europe and North and South America are the other two lines. That 20-25% in Europe of view hours on Netflix are actually from those portable devices. But the interesting thing is for tablets, 98% of that is Wi-Fi. And in many cases, that's just because the tablets are only Wi-Fi enabled. They don't have cell. And in phones, it's 10 to 15, perhaps up to 20% maximum of view hours are actually served off cellular networks versus off Wi-Fi. So the use case of someone watching Netflix on a phone, I think is very different from other video content, shorter form video content, like, for example, YouTube. Shorter content, more easily digestible on a small screen because you're just trying to play a 1-minute clip or something. Whereas when our shortest content's 25 minutes, you want to sit down, you typically don't do that when you're traveling so much. How are we doing time-wise? We've got a few more minutes? Yeah. So what I wanted to do is just sort of indicate again some of the constraints we have from an engineering point of view when we're trying to put enough storage in a single server so we could ship it out to a service provider. We're using commodity parts. We're trying to make this as cheap and convenient as possible. We're also trying to make it incredibly low power. And so this is our default box. It's a storage box. It's got 36 hard drives of the largest 8 terabyte form factor you can, 8 terabyte capacity you can get. It uses about 500 watts, so it's very efficient, and it has 2 10 gig ports, and this we use for within ISP deployments because it has 200 to 300 terabyte storage. And then we also have a flash server which at the moment only has 14 terabytes of storage, but it can serve 40 gigs of traffic, so it's much more efficient. It's about half the cost per gig of delivery. But we can only really cost-effectively use these in racks that's these guys, that are already backed by the catalog boxes. And so we can really only put the flash servers effectively when there's many hundreds of gigabits of Netflix content at that particular site. So think very large sort of metro peering areas. That's what I have. Hopefully you guys will have some interesting questions.
Right, fascinating insights. Any questions? There should be. Come on, guys, wake up. That's one-off opportunity here to have Netflix on stage. Yes, please.
Do you tune your recommendation based on what has been preloaded into the caches? So you recommend what is already cached?
That would be a great idea. We would love to be able to do that, but no, we don't at all. Okay. So we spend a fair amount of money in the team building out this delivery infrastructure, but by far Netflix spends more money on the content rights and producing our own original shows. And so we absolutely want to give the best consumer experience based on that, and so we never influence the delivery efficiency we could get by recommending one show to everyone just because it would be easier to serve. That never comes into the algorithms we use. It's a good idea though. We've thought about it multiple times.
Well, we did that with, just to chip in, so with King's worked with BBC quite a lot on the iPlayer problem. And we came up with some caching algorithms which would actually predict what you would like to see. And that would be cached actually direct on your smart TV, right? So really into the edge. So it's out of totally of your comfort zone. I'm not sure what the regulation there is, so we played around from an innovation point of view. But do you see a future there? Assume that the TVs really beef up, let's say, a lot on the capabilities, and you just literally download the most likely thing I'll be watching without me knowing it. I will be watching it.
I think there's some use cases, like when someone's binge watching a TV show, a TV season. Yeah. It's potentially much more likely they're going to watch the next episode. But we did a whole bunch of research about even within a neighborhood whether we could run some sort of peer-to-peer arrangement. And the reality is, even people that are watching runs of TV shows, they tend to dip into the rest of the catalog anyhow. And so the potential offload of that preload is is very limited, and potentially, you know, sub 20%, even in the best case scenario, and for many households, it's pretty much zero.
Yeah.
It's very, very hard to guess what they're going to watch next.
Yeah, well, I seem to have worked with the BBC because the content offering is so much more limited compared to.
I think a catch-up service is different because
exactly.
you've got, you know, day and date content that you want to watch within a week. I think it's now a month, isn't it? But still, it's most likely that it's the most recent sporting event.
It's a good one. Right. Any other questions on content delivery? Right. So yes, there's one from Ray. Yes, brilliant.
Just a quick question. So how would you compare your cache performance with commodity Akamai type of CDN?
So we have the number of streams we support off an individual cache is significantly more than they would be able to do, but they're trying to support a whole bunch of other content off the same infrastructure that they deliver for all sorts of other customers. And so we've been able to very much optimize that from a space and power requirement within an ISP. Probably 10.
Oh. Yes. Shh, can you wait for the microphone, please? Because we have streaming users. They don't hear you. Yes. Thank you.
Do you have any means of measuring the quality of experience observed by the customer, whether he's on a mobile device or indeed on a fixed device?
Yeah, so we have extensive metrics that come back from the clients about, we track a number of different things, 2 key metrics. We have the sort of time average bit rate that they've been able to sustain during the session. And then another one is just a general quality of experience metric around per hour, how many rebuffer events they have. And that's typically a very, very low number, sub 1. But we track that on different devices, on different networks to try and, you know, keep that number as good as possible. Then we'll reach out and work with individual ISPs to try and make those numbers, in one case as high as possible, in the other case as low as possible.
Okay. I have to say I'm a very, very, very happy customer of Netflix. So it seems to work really well. I'm not sure what you do, but quality is very good compared to the normal type of YouTube streaming. So that, you know, as a customer, you get, I think, a lot of value also in terms of content, and that's improving now over the years, as well as from the actual experience. So, you know, if you didn't get any Wi-Fi last night, that was because I was watching Netflix actually and having a good time. So let's thank David again. Cheers. Well done. Thanks.